Hi guys, Audrey here. So today we're just going to do a couple partial fractions examples. I might do a couple videos so that we can have different examples in separate videos. So we're going to start with a case 1 problem. Now remember, case 1 is when we factor the denominator, we end up with unique linear factors. So that's linear factors that occur one time. So when we see that happen, we'll talk about that again. In the meantime, let's remember what the steps for partial fractions are. So we're going to start with this integral right here, the integral of 2x plus 3 over 3x squared minus 5x minus 2. So this is our case 1 problem. So the first step of partial fractions is to divide if necessary. But notice the degree of the numerator here is 1, and the degree of the denominator is 2. So the degree of the denominator is bigger than the numerator, so we don't need to divide. So no division necessary. Now, the next step is to factor the denominator. So we want to factor 3x squared minus 5x minus 2. So this is going to factor in to 3x plus 1 times x minus 2. Now, if that factoring was a little bit challenging for you, let's see if we can remember how to factor non-monic polynomials. So remember, a monic polynomial is when that number right there, that 3, is a 1. So the number in front of the x squared is 1. Whereas non-monic quadratic polynomials are when we have a non-1 there. So to factor this thing, remember we're looking for 3 times negative 2 is negative 6. So we want a number that adds up to be negative 5, two numbers that add to be negative 5 and multiply to be negative 6. So I can see that negative 6 times positive 1 is equal to negative 6. Negative 6 plus 1 is equal to negative 5. So that gives me the two numbers that I'm going to use to factor this thing. I'm going to take those two numbers and I'm going to use them to separate the middle. So I have 3x squared minus 6x plus x minus 2. Then I'm going to factor by grouping. So I'm going to factor out a 3x here. And here, the only thing to factor out is 1. So there is no greatest common factor of that part. So we end up with 3x plus 1 times x minus 2. Perfect. So that's how we factored the denominator. So now the next step is to create our partial fractions decomposition. But in order to do that, we want to rewrite this thing like this. So I have 2x plus 3 over 3x plus 1 times x minus 2. Now, both of those factors occur only one time each. So 3x plus 1 occurs one time, x minus 2 occurs one time, which means they each get their own fraction. So we're going to have a over 3x plus 1 plus b over x minus 2. Now, our fourth step here is to find what those numerators are. So I want to know what is a and what is b. In order to do that, I'm going to start by taking this denominator right here, that 3x plus 1 times x minus 2, and multiplying it over to the other side. So we end up with 2x plus 3 is equal to a times x minus 2 plus b times 3x plus 1. Now, we are going to plug in the zeros of the denominator. So the first 0 that we have that's pretty straightforward is x equals 2. So we're going to plug that in and we get 4 plus 3 is equal to a times 0 plus b times 6 plus 1. So I get 7 is equal to 7b, which gives me that b is equal to 1. Now the next 0 comes from 3x plus 1. So where does 3x plus 1 equal to 0? It's going to equal to 0 when x is equal to negative 1/3. So that's going to be the next value that we want to plug in here. So x is equal to negative 1/3. We have 2 times negative 1/3 plus 3 is equal to a times negative 1/3 minus 2 plus, well, 0. It's going to make the b disappear. So I end up with negative 2/3 plus 3 is equal to a times negative 1/3 minus 2. That gives me negative 1/3 minus, we'll make a common denominator here, so minus 6/3. So we get 7/3 is equal to a times negative 7/3, which gives me that a is equal to -1. Perfect. Okay, so now that we have our numerators, our next step, our last step for partial fractions here is to rewrite our original integral in terms of that partial fractions decomposition. So we got that a was equal to -1 and b was equal to 1. Let's just go back and look really quickly. So my a was -1. That a goes over 3x plus 1. My b was 1, which goes over x minus 2. So this is 3x plus 1, and this is x minus 2. So now we're doing the integral of this. Well, now both of these are known forms. So we end up with -1/3 ln of 3x plus 1 plus ln of x minus 2 plus a constant for our final answer. That didn't work quite how I wanted. Give me a second. We want that pin back. Okay. That looks a little bit better. All right. So just a reminder, where did these known forms come from? Remember that we've seen that 1 over ax plus b dx is equal to 1 over a natural log of ax plus b plus a constant. So we're using this known form right here to evaluate both of those integrals. All right, that's all. Bye.